Okay, so example 2 in combustion is saying, all right, delta CH for methyl ethanoate is this number. Calculate delta FH. All right. The question never asks us to find delta FH. We know we're going to need Hess's law 2.0, and we're probably going to need a balanced chemical reaction. So we'll start with that. In order to write a balanced chemical reaction, I need to know the chemicals that are in it. So obviously I'm going to have oxygen, CO2, and water, but I need to figure out what methyl ethanoate is. So remember that methyl ethanoate is an ester. Okay, an ester has this sort of connection. Okay, now whatever's connected to the oxygen, remember, comes from the alcohol, which is this first part. So methyl means methanol, which means boom, 1 carbon alcohol. Ethanoate means 2 carbons are connected to this sort of carboxylic acid part. That's the first carbon always. That's the second carbon. So this is methyl ethanoate. Now what I need to do is write that balanced equation. I need to write the molecular formula for this, which is pretty easy. 1, 2, 3 carbons. Move it over. 3, 6 hydrogens, and 2 oxygens. Okay. Ethanoate is an ester. It's not going to be a solid. It's not going to be a gas. It's probably going to be a liquid. Could be a gas. I shouldn't say that, but probably a liquid. Again, I'm not like going to critique you guys on that. We don't know enough yet to really say what that is. Okay. Then I'm going to react this with oxygen. Products are going to be CO2. And in this question, it says bomb calorimeter. So water is a liquid. Okay. And I want to know, if I'm writing a thermochemical equation, I want to know what delta H is in kilojoules for this reaction. Okay. So let's balance this to start and then see what we need to do. Okay. So balancing this. All right. I got 3 carbons. That's a little awkward. Sorry, guys. 3 carbons here. Let's put a 3 here. 6 hydrogens. Put a 3 there. I got 3 oxygens plus 6 oxygens is 9. I got 2 here, so I need 7 more. Let's go 7 over 2. Okay. Now to figure out what, again, we want to keep this fixed at 1 because I have delta RH for this whole thing. And if I want to figure out what delta H is, all I need to do is take this and multiply by the moles. So if I want to figure out what delta H is, I'm going to do delta RH times N, which is going to be 1 mole times negative 1,592.2 kilojoules per mole. Again, simple math. We just want to show it. So my delta H is negative 1,592.2. Okay. Now I have delta H, but the question it didn't ask me what delta H was. It asked me what delta FH is. But I need delta H to get to that point. Whenever I hear delta FH, boom, I have to use Hess's law 2.0. So I'm going to erase this drawing so I have more room. And I'm going to say, okay, Hess's law 2.0 says delta H is equal to the sum of N times delta FH of the products minus the sum of N times delta FH of the reactants. So that's going to be, we know delta H, it's negative 1,592.2 kilojoules. Make that more clear. Okay, now my products, we got 3 moles of CO2, 3 moles, negative 393.5. And then water liquid, we got 3 moles times negative 285.5 kilojoules per mole. We know that oxygen's 0. And I'm going to write this in different colors so you guys can see. We don't know what delta FH is for this because that is what we're trying to solve. Minus 1 mole times delta FH. So we're trying to isolate for delta FH. So all I'm going to do is figure what this is, bring it over to the other side, divide both sides by negative 1 mole, and we're good to go. So I'm going to get negative 1592.2, that's going to stay. Figure out what this is right here. 3 times negative 393.5 plus 3 times negative 285.5. We get negative 2037 kilojoules. Okay. Minus 1 mole times delta FH. Again, what we're trying to isolate for. Bring this to the other side. So when I do that, it becomes positive. So I'm going to subtract that. So I get oops. So negative 1592.2 plus 2037 is going to give me 444.8 kilojoules is equal to negative 1 mole times delta FH. All right, I'm going to divide both sides by negative 1 mole to get rid of that. And then you should probably see what's going to happen. I'm going to get negative 444.8 kilojoules per mole is equal to delta FH. And that is our answer.